right, so here we have a multiple choice question. It's just the figure below shows three ropes tied together in a knot. Is this one of your friends pull on one of the rope with 3 newtons, another pulls on a different rope with 5 newtons as shown. How hard and in what direction must you pull on the third rope to keep the knot from moving? So this is a stationary problem since it says not moving. So here are our answer choices. You have 6 choices to choose from. So I will show you how to tackle this. Okay. All right. So the first thing we should identify is that the tensions that are being, or the forces that are being applied to this particular knot. In the blue, I will call that T1, and I'm just going to go clockwise from here. As you notice here, the angle given in the diagram is 120 degrees from 5 newtons to 3 newtons. However, I can break that up. So the red box that just came up, that's your right angle, that's 90. So therefore, that suggests that T1 is 30 degrees relative to the vertical axis. So once again, as you look at these diagrams, you just have to kind of, make sure your geometry is on point. I drew the vertical line across or straight up, and I know that the y-axis and the horizontal axis, x-axis is 90 degrees, but the angle given in the diagram is 120 degrees from these two vectors. So therefore, by deduction, I know that T1 is 30 degrees from the vertical axis, just using a little subtraction there. Okay, so 120 minus 90 is 30 degrees. And then, however, I know that T1 is pointing up and to the left. I like to reference that as the second quadrant in your coordinate systems. Hence, second quadrant would imply that you're going to go left and up relative to the knot here. So therefore, T1x is pointing left, and then T1y is pointing up. I don't like to use the angle that touches the vertical axis. I like to use the angle that touches the horizontal axis just so I can keep my cosinus x and my sinus y. So therefore, I'm just going to do a little basic subtraction. If this angle here is 30 degrees, therefore the angle between T1x and T1 is 60 degrees, because 60 plus 30 gives me another 90 degrees. Okay. If you like, you can use 30 degrees. Doesn't really matter to me. I like to use 60 degrees only because I know that x is cosine and then y is sine anytime you reference a angle that touches the horizontal axis. All right, so let's go and crack it up. I will call this 3 newtons as T2. Once again, I'm going to go from T1 clockwise to T2. And then last but not least, this diagonal that you're asked to find, I will label that as green. I'll call that T3. But T3, as you can see, is a diagonal in the third quadrant. It has a negative component in the y direction. It also has a negative component in the x direction relative to the knot. So I've labeled T1y pointing down, T3x pointing left. And then last but not least, before we start the math, the angle here that I labeled theta, it is the same angle as this angle here where my cursor is tracing back and forth. Okay, so that's also angle theta. However, I just drew my T3 pointing down here and then T3x pointing to the left here just so it's not so clutter. However, if you like, you can move T3x up here, which is pointing left, and then you can move T3y pointing down on this side if you like. If I just, like I said, I just drew it this way just so it's not so cluttered in this particular diagram. All right, so let's go and crack it out. It says you are applying a force that keeps the knot from moving. Therefore, it's suggesting that Fx, or in the net force in the x direction, is 0. So if you look at this diagram, the way I do it is T2 is pointing to the right, which is positive, and T1x is pointing left, and then T3x is also pointing left. So what I'm going to do is I like to write my positive first. I'm going to write T2, aka positive, first. And I'm going to subtract it from everything that points against it. In this diagram, I have T1x pointing to the left. I also have 3tx pointing to the left. And the net on that is equal to 0. So you notice here I already introduced my negative sign. I'm stating that T1x is indeed negative by having a negative sign in the front. And then T3x is also negative by having the negative sign in the front there. Okay, so I'm adding a negative. So keep that in mind. All right, so therefore, what I'm going to do is I'm going to solve for T3x. Well, why am I solving for T3x? Well, the diagram or in the problem asks for T3. So therefore, I know that I need to solve for T3, but in order to solve for T3, I need to find T3x and T3y, aka just the right triangle. You need to find the legs of these triangle or this triangle at the bottom in the green here, okay? Well, I know what T2 is. T2, based on my choice, is 3 newtons. Again, I just decided to call the left 5 newtons here T1. It doesn't really matter what you call it, as long as you're consistent. It doesn't really matter. The work will work out. So in my work, the T2 is this vector pointing to the right, which is 3 newtons, as stated in the problem. T1x is T1 cosine theta. Once again, T1x is your adjacent, and adjacent to what angle? Adjacent to 60 degrees here. Therefore, adjacent in geometry is cosine. Cosine of what? Cosine of the hypotenuse. So if you do cosine of 60, which is adjacent T1x over hypotenuse, and if you were to solve for T1x, you will get T1 cosine of 60 degrees, okay? So right away, we know what T1 is. T1 is giving us 5 newtons in the diagram. So therefore, we have 3 newtons minus 5 newtons times cosine of 60. And then cosine of 60 is a half. Half of 5 is 2.5. So here we have 3 minus 2.5, which is 0.5 newtons, which is equal to T3x. But I do want to remind you that T3x is negative, right? In the diagram, T3x is pointing left. When you get 0.5 newtons here, this is just the magnitude, because as I stated earlier in my second line here in the work, I'm telling you already that T3 is negative. So by doing this process, what you're finding is the magnitude of each of these vector or vector components. So I'm telling you here that the magnitude of T3x is 0.5. So using common sense though, T3x based on this diagram is pointing to the left, so it's negative. All right. So I know what the magnitude is. I can do the same process to find T3y. If you notice here in the diagram, T3y is pointing down, T1y is pointing up. So therefore, I can say T1y, which is positive, I'm going to do the positive first, minus the vector or vector component that acts against that motion is, in this case, it's just T3y. Okay. And if you've seen my other videos, I can move this component T3y. I'll do that again really quick here. So T3y in the diagram is drawn here so that I make a right triangle. However, if you like to, for the sake of clarity, you can move T3y to the left side. Okay. As long as you don't tilt the vector itself or the vector components, T3y is the same. So you notice here, you can move it if you like, and that would be the sign. Okay, so therefore I can see T1y, which is the vector pointing up here, equals to the vector pointing down, which is T3y. And that has to equal to 0. There's one arrow up, one arrow down. The difference in that has to give you 0, which suggests that T1y is indeed equal to the magnitude of T3y. This negative T3y is going to move to the right side, which makes it positive. So therefore, if I do this, T1y is T1 sine of theta, or sine of 60 degrees. So back to the diagram, T1y here is the opposite leg of 60 degrees. Okay, so if I reference 60 degrees with just the x-axis, T1y is my opposite, and opposite would imply sine, and sine is opposite, which is T1y over hypotenuse, which is T1. And if you were to solve for T3y, you would get T1 sine theta. Well, I know what T1 is. T1 is T1 is 5 newtons times sine of 60 degrees, and if we simplify that on a calculator, you just get a value of 4.33 newtons, which is equal to T3y. So back to this diagram here, okay? I know that T3y is pointing down. I also know that T3x is pointing leftward. So finding this is the magnitude, because I've already introduced all the signs for the components at the very beginning of my work. All right. So if we translate this into a right triangle, we notice this is T3, and then this is T3x, and T3x is pointing left. It has a magnitude of 0.5 newtons. T3y, which is pointing down using common sense, has a magnitude of 4.33 newtons. Therefore, the angle is here. Okay, theta is here. As I stated earlier, this theta here that I'm circling back and forth with my cursor because it's touching the x-axis, it is also the same as this thing, or theta here, that I'm kind of going back and forth with my cursor. I just put this right triangle down here just for the cleanliness of my work. But hopefully you understand that those two thetas are the same. All right, in order to find T3, we apply Pythagorean theorem. So I did T3 squared, which is equal to T3x squared plus T3y squared. Well, we already know what T3x is. T3x, according to this diagram, is negative. Oh, excuse me, I forgot the negative sign here, but it doesn't really matter because you're going to square it anyways. Okay, so if you like, put the negative sign in here. It'll be negative 0.5 square. A negative times a negative is a positive. And then T3y square. T3 in this case is pointing down, which is negative. So no, here, there's no hiccup. This is negative 4.33, and then we'll square that. But once again, negative square is just a positive value. So at this point, if you like, you can leave the negative signs out because squaring any negative value will give you a positive. All right. So if you do that correctly on your calculator, you should get that T3 square is equal to 19 Newton square. And then to get T3 by itself, we radical both sides. Radicaling both sides will give us T3, which is equal to radical 19. And the square root of 19, which is about 4.36 newtons. So that brings me to the answer choices. So the answer choices will eliminate the first four choices, right? Because we just found the magnitude as 4.36, which can be rounded up to 4.4. So here I'm left with these last two choices. The last two choices is 4.4 newtons, 4.4 newtons. But the only difference here is the angle. It says this one here says 76 degrees from the negative x-axis towards the negative y-axis. And likewise with this one, it says 83 degrees from the negative x-axis towards the negative y-axis. So in order to figure out which is the right answer from the bottom two choices, or the last two choices, I need to figure out what the angle is. So here in my diagram, the angle here is touching the x-axis. So therefore, I can just use tangent. Tangent of this theta is opposite over adjacent, which is T3y over T3x. And then if I were to solve for theta, we would divide both sides by tan, which causes it to turn into tan inverse or inverse tan. And then T3y, I left the negative sign out here because I'm just using common sense here, which is 4.33 newtons divided by 0.5. And therefore, that will give me an angle of 83.4 degrees. Well, as you can see here, theta here is 83.4 degrees. So the answer that resembles that would be the very, very last answer. Okay? All right, I hope that helps. Stay nerdy, don't be whack.